Alright, now we've seen all of the elements of operation of the AutoTune. Now it comes to the alignment. What do you have to do in alignment? That has to be done sequentially and in various steps. As you notice, that all the discussions in the past had to do with things like the switch reversing and so forth on the B dial, and the seeking return on the A dial. The rest of the dials, the rest of the AutoTune assemblies, don't really come into play as far as basic AutoTune operation. These have to track, the other three have to track. But typically when I go to a complete AutoTune alignment, I remove these three dials. I remove the whole heads, and they come out just by taking two, well actually there's three screws that hold it. Two screws are underneath the dial. You have to remove the dial, and you'll find two large screws in the top, and then there's one right down at the bottom that where this little notch is. There's a little Phillips head. There's three screws, pull that in, and it just comes right out of the gear system. Here is a separate AutoTune to kind of show you the two screws in the top. I put some nuts in the back side, but these, it's held in 1, 2, 3 positions. And that's what a typical AutoTune looks like.
You take these out and then just start by getting these totally correct.
Exactly, exactly. And these have little collars in the back that they can only go in one way. So when you put them back, everything's going to line up as far as that. Well, you're taking the dial off in order to get to these two screws, so you have to.
And again, the reason that these two are the leaders is because this dial, besides driving the PTO, drives the follower here that senses direction, that establishes direction,
and return,
and the A dial, besides doing its function on the multiplier, it also drives the switch that has the second of the two contacts for the channel position.
That is correct. Yeah. That is absolutely correct.
And that all has to be perfect before you can get these to drive.
That is correct.
Yeah,
that's
good.
correct. So now, what I'm going to do is, as far as alignment, suppose one of these switches is bent, or something's out of kilter. You want to check that. I don't have the text before me in the TO, but it gives you the specific point by point by point what you've got to do. Basically, it makes sense that, you know, this has mechanical stops to the dial. If you notice that as I'm rotating this toward the top side manually, the mechanical stop is just a little bit beyond the maximum reading. That is that physical mechanical stop, okay? Now, that means that this switch over here has to do its things, because the home position of that thing is at the upper end of this thing. And typically, I forget specifically right now, but you have to allow for the full range of the thing. Your mechanical rest point, when this comes to the end of its cycle, has to be beyond the mechanical range that you see here, beyond the zero.
But not against the mechanical stop.
It has to take place sometime.
So it has to be
between these
in
two
between
points.
Zero and the mechanical hard point.
Exactly.
Yeah.
And there's a specific, you know, the number of turns and number of degrees.
In the TO, there's the spec for doing that. Yeah.
Now let's come down to the other. I'm going to go all the way down to the opposite. I should like to point out that this is supposed to be a factory set, the upper one. And what happens, you've got a length that the worm gear travels versus a mechanical position between the two end stops. You know, these switches have to operate inside the mechanical end stops, but never outside, because you might have a mechanical end stop, and then that stops the operation of this thing. Right. You'll never get to the switch position. Now the other side, I'm coming down. You notice I'm going to the counterclockwise direction. This is what's happening in the actual AutoTune. And by the way, you hear these clicks? Hear these clicks?
Yeah, I can hear them. I don't know whether they're
I don't
going
know if
to
this
show
is
up
being
on the
picked
video,
up, but these have to be within like a quarter of a turn. See?
they're very close together.
Very close
They
together.
were like a 16th of a turn.
That's a proper AutoTune alignment.
Yeah.
And I'll get into how you set that. But let's go to the end down here. For proper AutoTune alignment, one of the things is you gotta learn to live with. There's a lot of cranking. Because you're going to be doing a lot of cranking for a proper AutoTune system. Now you notice the one-turn dials they're frozen at their mechanical stops already. Yet you've got we're only halfway through.
Now, I'll mention something that you said off camera, which I think is really relevant. There would be a temptation here to just leave the crank on there and run the AutoTune to get it to its end.
I can get to that
Yeah.
too. And I think we need to make sure. Because I say it happened to me once and it'll never happen again. See, there's no clicks in between.
Right.
That's what you want to hear.
And eventually, when you're working on tracking of these and these aren't at their endpoint, you'll hear all of these pulls dropping in.
Yeah.
And they need to be very close together.
Oh, by the way, I may have said something. I may have to do some editing on this thing. I just realized this limit switch has got to operate outside of your in limit. And
Oh, so it's got to actually take it to the mechanical?
I'll show you why. I'll show you why.
Oh,
We might point out, as we approach the zero of the mechanical dial, the 10-turn dial, there's your mechanical end. At that point, only at that point, is this switch got to open. If it opens before, that means it might select a channel before this dial got to zero. If you happen to have a frequency set up at
But
01
again,
on this dial,
but it should set up somewhere in between 0 and the limit.
no.
No?
In this case,
Oh,
here, I don't know if you can see it. Take a look around, take a look at the, yeah. We're coming to the other extreme of the rotation where we want the reversal. If you can see the contact, the switch is still open. I mean, still closed. Sorry about that. Now, we've hit the mechanical stop. The dial is stopped. And if you look at the contact itself, the switch is still in the closed position, meaning it's inhibiting a return of the AutoTune. So now, as we continue on, what's happening is the AutoTune is still operating. The open seeking switch back here is still turning. It's looking for an open. And that open has got to come after this mechanical dial has hit its in limit, so that if it did not do that, you'd get a premature return, and you couldn't, if you had a frequency set up close to the 0 point in this, it'll never get there. So during that period, and there's a spec in the book that says after the switch is open, which, looking at the top of the switch, just came about it looks like it's open. It's hard to see, but continuity looks like it's open. At that point, the system will start reversing. That means that we have found the proper point for all the poles to fall in.
Yeah, and you can see this came around to the gap just as that happened.
Yeah. So that's important. And I think, as I recall, the TO says, wait until the switch up again. We were talking about the alignment, the end limit alignment position of these switches. I think it's best to refer to the technical order on that. It's a case where you turn the crank such that the collar that runs this fiber shaft up and down no longer is adjusting the shaft. There's a slippage in that collar that goes to the screw worm gear. That's going to slip in the end limits. And what you're doing is that you're getting into the mechanical end limit so that the collar that runs that fiber shaft that goes up and down is no longer turning.
Right.
And then you back off.
You hit the absolute mechanical end
right.
limit, and the collar stops moving
Right,
on the
right.
lag screw.
Yeah, and then you back off. You turn in the opposite direction, and the spec is something like 3.5 to 3.25 to 9.5 turns. The switch should close or open or whatever the case may be, whichever switch it is. So enough said on that. Now I'd like to discuss the role of AutoTunes that you see here. I made a point that the key operation of the AutoTune system depends on the A dial and the B dial. The last three dials really have nothing to do with the AutoTune operation, yet they've got to be synchronized. And in fact, what I do on an AutoTune, when I'm doing a complete synchronization job, I just remove these last three and forget about them. And work with the A and the B dial. These are important. And some of the things that you need to know is I'm going to rotate this again here. And I don't know if you can see the rotation. Just a minute. Wait till it picks it up. All right. Let's go to the end here. Rather than crank through this whole thing. By the way, you notice I'm taking the handle off. I made the mistake once where I left the handle on, and oh my gosh, it almost wrecked it. The little tabs that go down into these slots can be destroyed.
You're talking about leaving the handle on when the motor is running.
And yeah, if you're going to turn the unit on, even accidentally, make sure that handle is. This is it. We're doing this to get it back to its home position. Can you zero in on one of these
Sure.
cam
Whichever one you
drums?
want.
Whichever one you want.
You tell me.
Uh,
Point to one.
Say this one since we're talking about that. Now, when I notice whenever the AutoTune starts, this cam drum, this is an indexing drum. This drum has to be an exact position on the reversal so that the little pawl of the pawl drops into one of the slots and freezes. That sets the pawl up. It arms the pawl to fall into the proper slot of whatever channel you've selected here. And you can see that now. You notice when I turn this thing on, these things are going to rotate. See, they're rotating. They're all rotating. And at the exact reversal, they're going to stop. See? Now frozen. And the reason for that, let's get this through. The reason for that, and here is a separate one, as these things rotate, these things rotate, they index. You see these poles that's what's happening. And what happens is that when the proper channel is selected, that pole for that channel has just got to drop in. And now when this reverses, there is a slip clutch, and this is kind of stiff. But yeah, here it is. See, it's rotating here. There's a slip clutch that allows the pole to be fixed, because when the pole drops in, it comes up against a portion of the pole here that it can't go. When it goes in the opposite direction, it can't lift out. In one direction, you know, there's a slant that goes down in so that it can go down in, but when it goes in the other direction,
it hooks on that.
It hooks on that because the cam is rotating in the opposite direction, so that's the one that's selected. And what that does is that arms the entire pole so that it will drop down into a slot when you're tuning. You see a little slot like that? The other end will drop down into that slot, and then lock that. Now this is. Yeah. That, can you see it locked down in when I turn that? And now that ring is locked. So when you open up the dial, which is hard. This is just a demo, and I don't know, people have probably... Oh, it's already, okay, it's open. I can see the one that's... I don't know if you can see this here, but that pole is dropped in that dial, and as we're rotating the dial, see that's called a stop ring drum. And that stop ring is fixed. It's fixed in that position. So it always stays in that position no matter what setting I have here. So whatever I lock this to whatever element is being tuned, it'll always come back to that same position. That's part of the, you know, it's a case where you index a pole to drop in at the right slot for the right channel. Then once you arm it, it'll drop in as this stop ring drum is rotating till it finds its little slot and fixes the shaft to that position. That's part of the AutoTune system.